Hello guys, welcome back to VC Tech. In modern networks, public IP addresses are limited, yet hundreds or even thousands of devices still need internet access. So how does a network handle that without assigning a public IP to every single device? The answer is Dynamic NAT. In this video, we will break down what Dynamic NAT is, how it works behind the scene, and why it plays an important role in managing IP addresses efficiently. If you've ever been confused about NAT pools, temporal IP mapping, or when dynamic NAT should be used, this video is for you. I'm going to make everything clear, as before we get into the configuration, let's have a knowledge about what NAT and dynamic NAT is. NAT is a network address translation, which is used by routers to translate private IP addresses into public IP addresses. It allows private networks to access the internet. It also conserves public IP address, and it hides the internal network structure for basic security. Why do we need NAT? IPv4 public addresses are limited, and most devices use private IP address. Private IP address cannot communicate directly on the internet. NAT solves that problem by acting as a translator between a private IP and a public IP. So for this tutorial, we are going to be talking about Dynamic NAT. And Dynamic NAT is a type of NAT where private IP addresses are temporarily mapped to public IP addresses from a predefined pool, which we are going to be creating when we get to the practical phase. And no permanent mapping is required. Public IP is assigned only when needed, and mapping is removed after the section is over. How Dynamic NAT works is an internal device sends traffic to the internet. The router checks the NAT rules and ACL and assigns a public IP address from the pool of IP address that we are also going to be creating in the tutorial. The traffic flows using the public IP address, meaning the IP address in the internal network will not be seen, only the public IP address that we are going to be using NAT to assign to the network. Mapping is deleted when traffic stops or when the section is over. The benefits of Dynamic NAT is the efficient usage of public IP address. It also hides internal private IPs, and it is easier to manage compared to static NAT. So with that being said, let's head over to our configuration phase where we'll be configuring Dynamic NAT on a router. For this tutorial, we are going to be using one router and one server which will be serving as the internet. Now we are going to be using these devices in the local area network to ping this server over here that will be serving as the internet. And for this local area network, it's making use of the IP address of 192.168.1.0, and this device right here is making use of 203.0.169.3. Now we want these devices to be able to ping this device with a different IP address. That different IP address is considered a public IP address. A private IP is not allowed to access the internet for security reasons. Now let's get into the configuration of Dynamic NAT on the router. So first, what do we do when configuring Dynamic NAT? We have to create an ACL rule, because we are going to be creating a pool of IP address, a pool of public IP address that will be assigning, or that these devices will be making use of whenever they want to leave the local area network to access the internet. They are going to be making use of that public IP address. First, let's create an ACL rule permitting the network. We are going to be creating a standard ACL rule. So IP access list and we want to specify that this is a standard access list, and also want to give it a number. So we'll be giving this number of 10, and we want to permit the local area network of 192.168.1.0, and that's 1.0.1.0 with a wildcard bit. Guys, remember to always add the wildcard bit so the ACL will not assume this ACL rule that we are creating to become a host. This is the entire network. So 0.0.0.255. We've created our standard ACL rule. Now let's create our pool of public IP address. So whenever this host devices in the network wants to make use of the internet, they are going to be using that pool of public IP address that we'll be creating. That is the help of Dynamic NAT. So how do we create a pool of IP address? We say IP NAT. Let me put this in caps lock. So IP NAT. We want to say pool as we have here. You notice we have inside, we have outside, we also have pool. So first we need to create a pool of IP addresses. So we say pool, and we want to give it a name. So for this we are going to call it dynamic. You can call it whatever name you want. So dynamic. Now we are going to be using the IP address on the outgoing interface, which is this interface. We are going to be creating a pool of IP address using this IP address over here, because this is considered the outside network. So the IP address on this interface is 203.0.169.0. So we are going to say 203.0.169. We want our public IP address to start from .20, and it should also end in 203.0.169. Let's say 23, because we have, or let's say 25, though we have just 3 devices on the network. And let's specify the network mask, which is 255.255.255.0. So by doing this, we've created a pool of IP address. If you notice, so from 203.0.169.20 to 203.0.169.25, we have 5 public IP address, meaning any device in this network, this local area network, could pick any of those public IP address that we've created to access the internet. And once that session is over, it comes back, and if it wants to go out on the internet again, it uses a different public IP address. That is why it's considered to become a pool of IP address. So we've created our access control list, which permits the host network, and we've also created our pool of IP address. Now let's bind the access control list that we created, the standard ACL that we created, and the pool of IP address that we created before we get into the next phase. Now how do we do that? We say IP NAT inside. Remember we had inside before. Let me show you that. So we have inside here. So we are going to say inside. We also want to specify the source. Then after the source, we are going to need to list out the ACL that we created. The list, you can check by just doing shift ? As you can see, we have our list over here, and we also have static, but for this tutorial we are going to be using list. So we are going to specify list, and once you get to this phase of list, remember to assign the standard ACL number that we gave to the ACL that we created. So we just list that there. So we say list should be 10, and now it's asking us for a pool. Also remember we created a pool here, which is IP NAT pool that we called dynamic. We called this pool dynamic. So we are also going to specify that over here. So we say dynamic, By doing this, we've linked the access list that we created to the pool of IP that we created also. Now let's get into the last phase of this tutorial, which is assigning the IP NAT inside and IP NAT outside on the interfaces on the router. However, if you don't do that, the communication is not going to go through, because the local area network devices would not know where to get their public IP address from. So how do we assign the IP NAT inside and IP NAT outside? On this local area network, the interface that is directly connected to the switch is interface gig 0/0. So this is considered IP NAT inside. And this interface that is facing the internet is considered IP NAT outside. So let's head over to interface gig 0/0 and we say IP NAT inside. Let's also head to interface gig 0/1 and we say IP NAT outside. By doing this, we've configured a dynamic NAT. We created a pool of IP address as we have over here, a pool of IP address, enabling this host device over here that whenever they want to make use of the internet, they should use the pool of IP address that we created. And we also permitted the network of 192.168.1.0. Then we bind our ACL that we created to pool of IP that we created. And lastly, we enable IP NAT inside and IP NAT outside on the interfaces on the router. Remember, the interface facing the local area network is IP NAT inside, and it's going to be making use of the public IP address of the interface facing the internet. So with that being said, let's try to troubleshoot. Let's do this. Do show IP NAT translation. As you can see, we do not have any IP NAT translation because we've not pinged the device from the internet. So let's try to do that. First, we need to assign IP address to the host devices. Then we try to ping and we check our IP NAT translation one more time. So 192.168.1.5, giving that one 1.5. Let's head over to the second device. .6. And let's assign IP address to the last device. So all our devices over here now have an IP address. Let's try to ping the internet and see what IP address it's going to be taking to get to that host. So let's ping what's the IP address. .3. So you're going to be pinging .3, 203.0.169.3. As you can see, guys, we are able to ping .3. Now let's go and check our IP NAT translation and let's see what's happened. So previously, when we did our do show IP NAT translation, we got no result. But however, after we pinged the internet server, we were able to get an IP NAT translation, and I'm going to explain what every phase here means. So this is the protocol that we use, which is the ICMP protocol. And the inside global is the public IP address of the internal device that was trying to communicate with 203.0.169.3. Now, the host device that was trying to get to 203.0.169.3 is the private IP of 192.168.1.7. We can verify that by going to this device, and you can see the IP address is 192.168.1.7, and it has the public IP address. It is making use of the public IP address of 203.0.169.20, and this private IP address is making use of the public IP address of 203.0.169.20. And remember, we created a pool of public IP address over here telling this pool that we want our public IP address to start assigning from .20 and it should also stop at .25. So that is why over here, when this private IP address, this internal IP address pinged this outside local, which is the server that we tried to get to, it used the public IP address of 203.0.169.20. If we also try to ping with this device, remember once the session ends, it returns the public IP back to the pool of IP. So let's try to ping with another device. Let's try to ping 203.0.169.3. Let's also go and check what public IP address it is using to get to that destination. It is also using .20 public IP address, and this is 192.168.1.6. Remember when we were explaining, it said that if a session ends, it returns the IP address, it returns the public IP address to the pool of IP addresses. This device is done making use of the IP address, the .20 IP address. Now the 192.168.1.6 internal device is now making use of that same IP address. Now how about if we try to ping the both at the same time? Let's see what's going to happen. So let's ping with this, and also let's ping with this, and let's head back and check our NAT translation and see what's going to happen. So for the internal device of 192.168.1.6, is using the public IP address of 203.0.169.20. We also have an internal device of 192.168.1.7, and it's using the public IP address of 203.0.169.21. So this is how Dynamic NAT works. It creates a pool of public IP address. So whenever the host devices in the network wants to make use of the internet, they go there and just pick one public IP address and they access the internet. And when they are done accessing the internet, they come back and they drop the public IP address and they sit back in the local area network. We can also check IP NAT stats. Now for this, it is telling us that we are using a dynamic NAT, and we also have an IP address that starts from 203.0.169.20, and the public IP address ends in 203.0.169.25, as we have the pool and also the name of the pool that we created to be dynamic. So guys, Dynamic NAT temporarily maps private IP address to public IPs from a pool of IP address, helping the network to conserve IPv4 addresses and also provide a secure outbound internet. If this video helped you understand how Dynamic NAT is being configured on a router and also how private IP addresses could change their IP address when they want to access the internet to a public IP address, why not smash the like button, subscribe to this channel, because in the next video we are going to be talking about NAT overload. Thank you guys, and see you in the next video.